We are getting into the tail end of our day, but we've got some great information still to come. Our next speaker, if you're from America, his name is Eric Forget from Nordic. But if you're from Canada, it's Eric Forget from Nordique. So I'm going to pass it over to Eric, and he is going to talk about their experiences here on Sanjak. And then I'm going to follow up talking about what some of the new code changes are. So Eric, if you are online, you can take it away.
Thank you very much, Mark. As Mark said, I am very disappointed I couldn't attend in person, sadly, as everybody knows, with the current state of the world, but I still did not want to pass up the opportunity offered by the college. So I will be presenting for Nordic Structures. We were the mass timber manufacturer on this project. And I do not seem to be able to share my screen. There we are. Apologies, everybody. So I will start off by introducing myself very quickly and also introducing who Nordic Structures and Les Chantiers Chibougamau, who is our actually is our mother company, are. So for me, I have an architecture and engineering background. I have a college degree in architecture. I did a construction engineering bachelor's, and I also have a master's in business administration. I am a registered engineer in the province of Quebec. I have worked previously to Nordic on various complex projects around North America, namely the new Champlain Bridge in the Montreal region that crosses the St. Lawrence River, as well as the McGill University Hospital, that is a super hospital in the Montreal area. Closer to you guys, I have also worked with teams that have done preparatory work on the Sam Houston Bridge, as well as the Corpus Christi Harbor Bridge. I've been with Nordic for 2 years now, started as a project manager and am now a project manager and team lead. Our company, Nordic Structures, is a subsidiary of a company that is called Chantiers Chibougamau. The sawmill and transformation plant is in Chibougamau, Quebec. For anybody that's not familiar with Chibougamau, which I doubt you are, it's about 800 kilometers, so 500 miles north of Montreal in Quebec. So if you see my cursor, it's right up here, and Houston is right down here. About 2,215 miles from our factory to the San Jacinto College site. We are a vertically integrated company, meaning that we own our own forests, forestry service, and we also do our harvest and replanting ourselves. We have the sawmills that do the transformation of the raw wood, either to construction wood or to our engineered wood products. It's a privately owned company that was founded in 1961. It's a family business, and I am currently working with the third generation. So some of my colleagues are the children and grandchildren of the founder. We are now 700 plus employees in Quebec. Some of our employees, very few in the States and Ontario as well. And we're currently the largest glulam and CLT manufacturer in North America. The Nordic branch is for the sales and pre-construction support. Obviously, we do engineering, drafting, and we manage projects, and we offer a turnkey solution, meaning that we actually harvest our wood, transform it, deliver it to site, and offer the installation services as well. Quick history. So the company was founded to harvest for the mining industries with 5 employees in 1961. In the 70s and 80s, the construction industry started picking up some speed, so the first automated systems were installed at the factory. In the 90s, we got the finger jointing technologies that allowed us to start doing I-joists. In the 2000s, we have the FSC certification that we obtained, as well as some certifications for our industrial laminate products, as well as our I-joists. In the 2010s, early 2010s, we had our CLT plant that was constructed, and we started manufacturing CLT, I believe, in 2013, which allowed us to start making multi-story buildings. As of today, we are part of a lot of major projects all around North America. We are an industry leader as well, and as I said earlier, 700 plus employees between Chantier Chibougamau and Nordic Structures. And so our factory on the right here is about 2 square miles. To give you an idea of the size, you see the village of Chibougamau right under it, south, to give you an idea of the size, again, of the factory. And so Nordic, as I said, we offer technical support, design assist, which we participated on the San Jacinto College, connection design, plans and modeling. We also, obviously, as I said, offer production services, glulam and CLT production, the shop drawings, the CNC equipment. We also fabricate our own steel connectors. And finally, the installation. As I said, we did the installation on San Jacinto College. So we supervise, install, and coordinate with the general contractors in order to erect our buildings. It's to note that we have also people that sit on the board of the Canadian Wood Code Committee. We have a research and development department. We also have technical support for industrial and residential products such as I-joists. So we're very interested and implicated in the mass timber industry. And so, as I mentioned, we supply glulam and CLT, and you can see all of these certifications that our engineered products have, namely the FSC certification, as I mentioned before. We are part of we have product reports certified by the APA, as well as our products in factory. We have American Wood Council as well. So all of that is the certifications that our engineering wood products have. And just a quick look at a shot of our glulam factory on the left and our CLT factory on the right. So gluing, CNC machines, the wrapping, packaging, and whatnot. I also wanted to do a quick review of the possibilities that you have with mass timber. And so the projects that I will show are all Nordic projects, and specifically in Quebec and Ontario only. If you are interested in seeing more mass timber projects, we have hundreds that are on display on our website, and they are basically all over North America. And so we basically have projects in multiple different scopes of work. Library on the left here in Toronto, Ontario. We have in the middle a sports facility in Montreal. The roof beams that you see there are actually 200 feet long. They needed to be assembled in 3 pieces to be able to be erected. On the right here, you have a furniture store, so similar to the Rent-A-Centers that you have in the States. So we have a lot of them all over Quebec. Then we also do offices and headquarters. This is the JSK head office in Quebec City. And if you ever drive on the Trans-Canada Highway in the Montreal region, you will also possibly pass this building on the right here, which are offices. And 2 projects that we're very proud of. This is a multi-residential complex in downtown Montreal. It's actually 5 minutes from the Nordic office. They are 3 buildings, largest mass timber project in the world still today. 600,000 square feet, 434 condo units. And it's a project that we're very proud of because we developed it as well as built it. And then this one is also very interesting because it's the highest all mass timber building in North America. And what that means is basically the envelope walls, the cores, and the stair shafts are all made of CLT as well. So it's an all timber building. It was erected in 16 weeks. It's in Quebec City, and it's a 13-story building. So a few pictures of the erection and the project modeling as well. And so we also manufacture some timber bridges, which I don't have any examples here, but we do that for our own forestry service and harvest up north. And San Jacinto is actually the first project that we have in Texas. There is another one that's scheduled for this fall in Houston as well, which is actually a CLT floor and roof on a steel structure. And so to get to the main items that I wanted to discuss here, Nordic's experience basically with the San Jacinto project. So the highlights for me as the project manager. So to start off with, it might sound, I guess, ridiculous or simple, but one of the things that made this project work very well and go as intended as planned is the owner was actively part of the design and coordination meetings. So every meeting that I had for coordination with Mass Timber and the subcontractors, Mr. Smith was there. He always provided his input, and I think he was very active as well on the design side with Kirksey and Walter P. Moore. Obviously, the active participation of the owner will help have the final result as you desire it, and obviously guide your design team, your general contractors, your subtrade partners, such as us, the mass timber manufacturer. It also very much minimizes the possibilities of having change requests later on when we've started fabrication, or even worse, when the material is already at site and the constructions began. Obviously, it's very costly to do so at that point. So having the owner on board very early and in all the meetings helps avoid most of that. And also having an owner that's a partner and proponent for the mass timber industry for us as a mass timber manufacturer is very interesting, obviously, to work with. Furthermore to that, obviously, I think the college has associated itself with people and companies that are also interested in the project. And in this specific case, it was a mass timber project. I know Kirksey was very interested in the mass timber structures. Even today, after pretty much all of our work for Nordic is done on site, I still get calls from their team asking for questions and information about mass timber. So it's nice to see that even though the project is pretty much completed for us on the structure side, they're still showing interest and interested in learning more basically about mass timber structures. And the exact same thing can be said with the general contractor. I speak with Tellefson people very often for questions for possible other projects. They're looking to bring more mass timber into the Houston area or even Texas, looking to maybe convert some steel buildings to mass timber instead. So it's very interesting to work with people that are actually interested in the material. And so that's one of the things that made this project very nice for us to work on. Another positive thing that was done on the San Jacinto project, Nordic was awarded a design assist mandate very early in the process. So I think, if I'm not mistaken, we started being part of the project in February 2020. And so basically we were on board all along for the structural design. So obviously the sizing of the structural elements we helped with. We made sure with the structural engineers from Walter P. Moore that everything was sized accordingly. Also to optimize pricing in sections, we made sure that it was optimized to our standard sections as well as much as possible. And obviously, since we were on board and the NEP and fire protection trades were on board as well, then parallel work could be done to further design and find any issues quickly that you would potentially see if they weren't on board. I have an example of this on the right here. So the openings on the two-story, I believe it's a conference room on both levels. The architects wanted the ducts to go through the beams, and obviously, as you can see, these are substantial openings. And so these required the addition of reinforcement screws to avoid splitting of the wood around these openings. And so knowing that for us and being able to fabricate it and install it at the factory made it so much easier than if this coordination was done when everything was designed. So that would have necessitated reiterations and re-looking into the sizing of the beams. As well, since everybody was on board, we have no surprises when going to fabrication, as the routing for the ventilation, as I said, but also for the fire protection. In this picture on the right, you can also see some junction boxes for the lights. So pretty much all of the openings were coordinated before we released anything to fabrication. And so basically the summary of what I'm saying is the San Jacinto College project adopted a very aggressive, in a very good way, approach to integrating everybody in design assist. So as much the structural as all of the mechanical, electrical, plumbing, and fire protection subtrades, which we have honestly rarely seen on projects, and which we are pushing to become standard practice, because as mass timber is still a new material in the industry, I think it's important for everybody to be on board as early as possible in order to save time on the design schedule and be on site on time as well for the construction. The other thing that was started early was the BIM coordination between all trades. So obviously that benefits the project because we can prefabricate pretty much everything in the mass timber, penetrations and openings, as I've mentioned before, and as you can see again on the right here in the beams and in the CLT slab. And it also gives a chance to the architect and the structural engineer to have their detailing on the model easier and figure out their details easier, since everything is in place and is routed where it's supposed to go. I spoke about the prefabrication already, but the general contractor on this project was very prefabrication minded, oriented. So basically everything that we could prefabricate, we did. And so obviously there's multiple advantages to that. One being that the CNCs are a lot more precise than when you core and cut in the field. So the cuts are clean and they're done very, very cleanly. So there's no wood breaking or wood flakes around the openings. The other thing is it saves a ton of time and costs as well, because we include it in our manufacturing costs, and it basically takes seconds to do on a CNC machine versus maybe 10 to 15 minutes, depending on the size of the penetration at site. And so this is very time consuming and costly to do at site. Generally, what we recommend is 6 inches plus to be done on the CNC, anything else smaller to be done in the field directly. In this case, Tellefson was adamant that we do as many penetrations as possible in the factory, which is what we did. I think the smallest ones we did were about 2 inches in diameter. And obviously, with that in mind, it's important to coordinate the openings and the penetrations during the design phase to make sure that all of the prefabrication benefits can be enjoyed. If it's not coordinated in advance, well, obviously we need to fabricate at a certain point, and then everything needs to be done at site, which comes back to the cost and time difference between doing it in the factory and that site. Also, the other thing about that we need to be mindful of is the mass timber erection tolerances. So obviously we core at the factory with a 1/16 of an inch tolerance or precision on the machines, but the erection at site can obviously be a little more since there's multiple factors that generate some tolerances here and there. The concrete, the benchmark elevations and whatnot are some that are generally critical. And so I just wanted to put a screenshot to show the coordination plan. I believe this is for level 2 of the 3-story building. And so all of the penetrations in blue were decided to be cored at site. The reason for that, and we suggested that, is because the corridors are about 300 feet long. And the architects obviously wanted this to be aligned on 300 feet. So all the junction boxes for the lights, we wanted to be aligned as well. So since the panel layout was north-south here on the drawing, and the erection tolerances are generally about 1/4 to 1/2 an inch, we preferred these openings be done at site to make sure that the alignment of all the junction boxes was good from east to west all along the corridor here. The other good thing, we had done this previously on one project, but the client and the general contractor were definitely on board with this option here. So 100% of the wood volume for the project was shipped by train. So basically it was shipped from our factory in Chibougamau to a reload facility that's about 10 miles off site in Pasadena. And so basically for this project, it was very cost effective because we had sufficient volumes, and you have 48,000 pound load limits on trailers in Texas, which basically by train, we can ship about 3.5 to 4 trailers on one wagon. And so you can see here what that looks like. So we shipped all the glulam, which is the first picture on the upper right, by wagons, as well as all the CLT, which are the second and third pictures here on the right and on the bottom. And so one of the benefits of shipping by train, obviously, mass timber is a carbon neutral or carbon sequestering material on this project. And I believe it was probably mentioned earlier today. We have about 2,500 cubic meters of wood. Generally, the agreement is that a cubic meter of wood sequesters a metric ton of carbon. And so by shipping by train, we also reduce the project footprint by about 170 tons of CO2. The material is stored locally, so it acts as a buffer in case of any surprises. There's obviously less chances of any impacts on the schedule because the material is only 10 miles from site instead of being 2,200 miles from site. So that's basically the buffer acts as a peace of mind for as much general contractor as the project manager. So me in this case on our side for this project. The only thing that you need to consider if you're going to consider shipping by train is you need to plan in advance, obviously, because the transit time for a truck from our factory to Houston was about 4 or 5 days. With a wagon, it was about 18 calendar days, if I remember correctly. So obviously the planning needs to be done so we can ship the material in advance. So fabrication has to be completed in advance. So approval of drawing has to be completed in advance, and so on and so forth, obviously. The other good thing about this project, obviously, mass timber is we sequenced the project to erect the 3-story building in 2 phases. So basically this was to allow the subtrades to start working as soon as 1 floor was erected. And so you can see here, basically, this is what happened. As soon as the CLT above was erected, it's safe for the subcontractors to work under the continuing erection above. And so I just have 2 screenshots here, the site camera showing that the lights were basically installed as soon as the floor was completed above, and the subcontractors started working as well, safely protected under the CLT. One thing that we have to be mindful of, though, for the installation of any material before the building is watertight is obviously installing any humidity sensitive materials. Just have to be careful to make sure that they don't catch any water, and that would eventually, I guess, create mold. So we just always remind people to be mindful of that the work can start under the erection of the continuing building. Just be mindful that it's still not watertight. Also, obviously, I was talking about water, which brings me to talking about a moisture mitigation plan. And so the general contractor here was very proactive in looking into this very early and coordinating with us, asking about our previous experience on how to handle the water with a mass timber building. So obviously mass timber is not very sensitive to water, but it's more in terms of the finish. This is obviously an architectural product to a certain extent, and so we want to avoid water staining. And so in this case, you can see the picture here. The general contractor had tarped the whole building to avoid water coming inside for multiple reasons, obviously. So there is an acoustimat under the concrete slab, and it was to avoid having any water standing under there before they poured the concrete. But in the same time, adding that temporary membrane on the roof allowed the wood to stay clean and dry. And so We haven't seen this very often either. So hats off to the general contractor for basically consulting with us and also having a moisture mitigation plan in place. That saved a lot of headaches, obviously, on this project up to now. And so, yeah, strongly recommend anybody's looking into a mass timber for a building to definitely think about that very early. And so with any project, obviously, there were a few learning opportunities. I was talking about fabrication and erection tolerances earlier. So we had a little snafu on this project with the pre-cord penetrations inside in the factory. So basically what we noticed when we got to site, some of the sub-trades started trying to install their sleeves in the penetrations and the slabs, to notice that the dimension that we had on the coordination drawings were actually the size of the conduits and not the sleeves. And so sadly, as you can see on the picture, we needed to recore a lot of the penetrations that were done in the factory on site. So obviously there are costs that were associated to that and more time than we were expecting as well. So just be mindful of that in coordination during the design phase. And I was talking about the installation tolerances for mass timber earlier. Mass timber is not really any different than steel or concrete, so we generally try to stay within 1/4 to 1/2 inch of tolerance from the dimensions that we have on plan. And the details, regardless of architectural, structural, whatever they are, obviously need to be adapted to this reality. So on this project, I think there was a detail for the edge of deck that required the deck to be basically perfectly placed. And so on the picture here on the bottom, you can see the line on top here, which is basically about 1/4 of an inch that needed to be cut off on the edge of the deck to be able to have that detail, which I believe was the fireproofing on the edge of the deck. And so this is basically just to remind that there are erection tolerances and that any details that have to fasten to the mass timber structure need to account for a small tolerance at least. In terms of installation tolerances, obviously the important thing to check before anybody gets to site is the anchor bolts and the concrete elevations, and also the plumbness of any non-wood elements that we would be connecting to. Obviously the wood is fabricated within about 1/16 of an inch of tolerance, as I was saying earlier. And so it's not always obvious when you need to connect to either concrete or steel. A quick example of this on the project here, the CMU wall in the lobby between the existing building and the new building was basically out of plumb. And so as you can see on the left here, one of the wind girts that was supposed to be installed with a steel connector to the CMU wall was not able to be installed properly at that point. And on the right, I put the actual detail from our erection drawings to show that we had actually planned for this by leaving a space of about 1/2 an inch between the back of the plate and the CMU wall for a non-shrink grout fill-in to make sure that we were able to install this plate. And so it ended up that we were able to straighten out the CMU wall. It was corrected, and we were able to install the plate. But I thought this was a very good example of things that you really need to be mindful of when you're erecting a mass timber building and you need to connect to anything else, steel or concrete. And finally, another thing that I think is very important to remind, we are a mass timber structure manufacturer. We generally pretty much 95% go off of the structural drawings. And so it's important that all the information that's reflected between the architectural and structural drawings be the same, and also making the changes clear on the drawings. Mostly, I think the important thing that should translate from architectural to structural is the grid lines and the edge of decks in our case. So the CLT is cut to a certain length desired by the design team. And this needs to basically be reflected on the structural drawings as well to make sure that it's accounted for since we mostly work off the structural drawings, being a structural manufacturer. The good thing about this, though, is with wood, it's generally pretty easy to fix on site, most likely easier than steel and concrete. So if there are any mistakes or omissions, then generally we can fix it pretty easily without any stress or any major problems or changes. And so I would just like to conclude my presentation with a few pictures of the fabrication process at the factory. I think it's interesting to see the intricate details and the intricate work that we can do with a CNC machine in a material like wood. And so here, basically, there are 3 different pictures of the columns that were fabricated for the San Jacinto project. So on the left, you can see a major slot and shear key at the bottom there for a gusset plate for a brace bay connection. So you can see the amount of dowels that are also required here to transfer the loads between the structural elements. Same for the middle picture there. You can see the shear keys and the dowels, so everything's adjusted to tolerance. And basically, as I said, it's fabricated within a 1/16 of an inch tolerance to make sure that everything fits snugly and there's not too much gaps between the elements. On the right here, it's a pocket for a bearing connection, a beam bearing connection. And an interesting thing also that we put to make the lives of our erectors easier. I don't know if you can see my cursor here, but right on the right picture here, we have our label, and you have a small little round machining there that we put to indicate the northeast corner of the column. So to make sure that the machinings are in the right direction to receive the right beams. So that's something that we include in our manufacturing process to simplify the erection for our erectors. Here is another example of beams. We machined the tops for the top plates of the hangers in the factory to spec. You can also see on the left picture here, the sprinkler penetration was machined in the factory, so to a 16 tolerance as well, as I was saying. In the middle is an example of a knife plate for a hanger. You also have the machining here for the bottom plate where the beam rests for the gravity loads to transfer to the columns. On the right here, those of you that will have already done the visit will probably recognize the suspended rods for the beams in the lobby. So these were fabricated and powder coated at the factory, and the rods were basically connected by couplers. So all of that you see right now, and that you'll see basically for the life of the building is the non-threaded part in the middle. And so this was powder coated to the architect's desired color in the factory. Finally, the CLT panels. So you can see here basically a machined CLT panel. On the bottom left here, you can see that the machining for the plywood splines are done at the factory directly as well. You can see that it's a 5-ply panel, so they're 5 5/8 panel that were used pretty much everywhere in the project here. I think just the roof of the lobby, if I remember correctly, was a 4 1/8 panel. And so you can see the machining that was done for the column, the base plate of the column and hanger. We leave some space for all of the welds as well on the steel hangers that we fabricate ourselves at the factory. In the back here, you can see a bunch of panels that were already fabricated, waiting to be stacked in the right order and packaged. For information, the packages on the right here are stacked in the erection order on trucks. And so basically it avoids double handling at site. So the erectors basically just install their lifting brackets directly on the panel on the truck and lift it in place. So they don't need to handle 10, 15, 20,000 pound packages at site twice. So it saves time. It also saves any possibility of damaging the panels. So it reduces all of that. And so with that said, this is the end of my presentation. Thank you very much for the opportunity again. San Jacinto College Nordic appreciates being a partner on this project. I'm very sad I could not visit today. I would have loved to see the building erected, but I guess it will be for another time. And I guess we can go on to the Q&A.
Does anybody have any questions for Eric?
I think he said the plumpness of CMU wall is needed to be corrected. Does that mean CMU wall was rebuilt?
No, we noticed that the CMU wall was out of plumb by about an inch from top to bottom when we came to install notably our wind girts that I showed the picture of. And so the CMU wall was supported by temporary bracings. And my understanding from the erector is that it was temporarily tied back to the existing building structure as well. And so what ended up being done is I believe the tiebacks might have been removed temporarily to be able to replumb the wall in place. And so we didn't get the full inch back because we weren't able to have that ½ inch of grout behind the plate. But we ended up being able to fit the connecting plate to the CMU wall in and make everything work.
What else? All right. Well, Eric, thank you very much. Appreciate your input on the project. Very interesting.
Thank you very much, everybody.
I don't know if you can see me. I'm going to wave. All right. So I am up next. So I finally got a chance to talk. So I'm going to walk around. I got the handheld mic. Nobody can keep me on time, so I can go as long as I want, right? I got a clock right up here, so I can keep track of basically where I am in time. So I'm going to be talking to you today about something that I find very interesting, and we're going to see exactly how embraced this is by the industry. I get the guys in the camera. Do I need to just not move around so much? I stay right here or do what I want? Okay. All right, excellent. So skip through this stuff real quick. So what are we going to talk about today? We're going to talk about what is tall wood and how tall is tall. You know, what is our code allowing us to do and what are the codes going to allow us to do? What we have seen done, what products are used. And I'm going to go through that really quick because we already sort of talked about that. And then basically we're going to talk about how we arrived at changing the building code and what research we had to do to make everyone assured that what we were doing was safe for the occupants and the owners of these buildings. And then I'm going to go through at the end exactly what we're dealing with in the new version of the code. So when you look at the existing codes we have, and I'm talking about the IBC 2018 and older, you know, our heights and area limits that we had were really based on some really old information, the 1910 Heights and Areas Act. So if you went with B occupancy for wood construction, you were limited to 85 feet and 6 stories. For multifamily, it was 85 feet and 5 stories, although you could squeak a mezzanine in there to try and do that. Anything taller than that, though, you had to go through an alternate means and materials request with the authority having jurisdiction. So you had this sort of limit that was not necessarily based on the performance of how the material could do, but it was based on these sort of old prescriptive code requirements that have been around for a long time. Now, one of the things I want to stress is that mass timber and tall wood is not light frame construction. So we are not trying to go tall with light frame. What we have in our current codes has proven to be very effective for light frame construction. And so type 3 construction, type 5 construction are staying the same, and that's where we're going to find light frame construction being used. But when we get into mass timber, we've traditionally been bouncing around between type 3, 4, and 5 construction, wherever mass timber sort of fits in based on fire resistance ratings and occupancies and whatnot. But we were still limited to those same heights as light frame. And so now we're going to be looking at something a little bit taller. So what have we seen across the pond over in Europe? We've seen them pushing the limits of what tall wood can do. So back in 2015, that's when we really started to look at going taller than this sort of 6 stories and 85 feet. And over the years, it has progressed taller, a little bit taller, a little bit taller, and so forth until we get down to the final image on the lower right. That's a project in Norway that was around 14 stories tall. So we were starting to see some projects that were pushing the limit. And then we really started getting into what we're seeing here recently, and that's pushing it up into the 18 to 24 story limit. So the image on the far left is a project in Norway. The image on the far right is a project in British Columbia, Brock Commons. And that one was really closely aligned with how we are looking at doing those same types of structures here in the United States. So what's the tallest modern wood building in the United States? It's this one right here. This is Carbon 12 in Portland, Oregon. It's an 8-story condominium project. Funny thing is the tallest wood building in the United States is the Butler Building in Minneapolis, which was built over 100 years ago. So over 100 years ago, before we had building codes that said, hey, you can't build that tall, we were already building that tall. Now that's a heavy timber warehouse that's been converted into office space, but it is a still building that's over 100 years old and still standing and still being used. And I've got to tour that building. And if you ever get up to Minneapolis, go into the Butler Brothers building, it is the coolest thing to see some of these massive solid sawn timbers that came from a single tree that now have big splits in it and checking, and but they're still standing and it's still performing exactly what it needs to be. So what are the products that we see? I think Kirksey already covered these in a previous presentation, so I'll go through them a little bit quickly. Glue lam, cross laminated timber, nail laminated timber. Although nail laminated timber, it's got its little niche, but you're not going to find any manufacturers mass producing NLT panels. But if you want something where the contractor can self-perform some mass timber installation without involving a manufacturer, then they can self-perform an NLT project. It's not very complicated to do. DLT is sort of taken over for dowel laminated timber. That's something that you can get from a manufacturer that's going to be prefabricated. Mass plywood panels, a very close related cousin to CLT. And then even more traditional materials like tongue and groove decking still comply with heavy timber requirements in the code. There was a project in Sacramento that was just completed using heavy timber decking or tongue and groove decking, but it's not something that be prefabricated. It has to obviously be cut on site. And we have seen these projects come across the United States in a wide variety of applications, from offices, multifamily, commercial, and like we see here, educational projects. We've really seen an embracing of mass timber across the United States, and we see a wide variety of buildings. So what are the drivers for mass timber? I think one of the drivers, if you've been on one of the tours today, is simply obviously the aesthetics of the space. Working and living in a space like that is just, it's hard to compare. There's obviously some construction advantages to it as well, and obviously Telepsin has talked about those as well. Sometimes you're going to see some advantages in construction speed and potentially some reduced foundations, things of that nature. There's a lot of drivers for mass timber, and you're not always going to take advantage of every single one of them on a project, but there's usually going to be one in there that sort of is the key that drives you towards it. So this image right here is just sort of a perfect example. Now, this image cheats a little bit. Okay, and I'm going to say that because most of the time, if you're building in a concrete building, you're not going to leave the concrete exposed because it is not attractive. You're going to cover it up with some sort of ceiling, which obviously in mass timber, you don't have to. And so you're able to utilize that structure as the finish and see that, that beauty in the space. So mass timber in the United States. We've got a lot of projects that have been done. Most of these have all complied with our building code requirements as far as our heights and area limitations. The one on the upper left, that's the T3 project in Minneapolis. Has anyone here counted the number of stories on that? 7. You can't do 7, right? That we can. Podiums. That's got a concrete podium and 6 stories of mass timber on top of it. So it still has to stay underneath that 85 feet. I'm guessing their floor-to-floor heights are pushing that building to where they can probably slide a playing card underneath that 85 feet, and that's about it. But we're starting to see those projects push it by utilizing podiums. The new versions of the code, we won't have to worry about doing podiums if we want to start looking at going taller. So building code status, most of us who are engineers and architects in this room know that every 3 years, they tinker with the code a little bit, make changes to it, some good, some not so good. And then you got to relearn things. And then you got to wait for your jurisdiction to adopt it and things of that nature. So every 3 years we have to deal with this. So the most current one that has been adopted to a large scale is the 2018 IBC. The 2021 IBC obviously has been published, but we haven't seen widespread adoption of it yet. but we are obviously working on that. So the 2015 code was very revolutionary when it comes to mass timber because it was the first one that mentioned CLT. It defines it, it lists it as an acceptable building material, and it lists the certification for CLT, the APA PRG 320 certification. And so that was literally the first code that said, okay, you can go ahead and use CLT. Now, CLT was being utilized in projects before this, but it was mainly where they had to go through that process with the authority having jurisdiction to get approval for it. This obviously laid out a very clear code path that allowed us to use CLT. NLT, it's been in the code for years. They call it mechanically laminated decking. It's been around for a very long time, but it just wasn't something that was utilized. CLT was really the product that came in and sort of kicked everybody in the butt to sort of move this mass timber movement forward. So almost immediately when we got CLT in the code, though, we started looking at all these really cool projects that were occurring over in Europe and up in Canada and some down in Australia. And so there was a lot of interest in potentially doing tall wood within the United States. But the hurdle of having to get approval from the authority having jurisdiction was way too much of a hurdle in a lot of cases. That project I mentioned in Portland, Carbon 12, they had to go through a statewide approval project to have an independent group of architects, engineers, mechanical and so forth come in and evaluate the building and make sure that it was okay. It's just not something that's going to be pulled off on a lot of jobs. Most of the time, you just don't simply have the budget to pull off doing that much additional work to have it go through the authority having jurisdiction. So tall wood pretty much has just not really happened in the United States because of that process. But there was still a lot of interest in it. So an ICC ad hoc committee was formed to investigate basically changing our building code to allow tall wood within it. So this all started back in 2015 in December. They established this committee and they were going to go through and look at all these different objectives, exploring the science of tall wood, the feasibility of it, and then take action basically on what those code changes were going to be. So just as far as a timeline goes, they submitted in January of 2018 for changes that were in the 2021 IBC. So 5 working groups were created and they had a bunch of meetings and they had talked about a lot of things. There were concrete representatives, there were steel representatives that were in these committee meetings. They were not happy about these solid wood changes. They were not actively trying to get this to happen. And so there's been a lot of, and you might have seen ads in magazines that talk about, some of the things that the debating that's been going on back and forth. So 82 issues were addressed. The most important one was fire protection and life safety. And obviously, when you start talking about tall wood, you're talking about buildings that can have a lot of people inside them. And you want to basically protect the occupants of those buildings. You know, if I just stood up here on stage and said, who here thinks building 18 stories out of wood is a good idea? There might be some hands that are like, I don't know about that. 18 stories? That's an awful lot of wood in there. So obviously that's the first thing they needed to address was the fire protection and life safety of the occupants. Now, when we talk about what's in the code now, it's very well defined. We're allowed to do exposed mass timber in the code. And basically there's this path that says in the IBC, it says, okay, you got to look to NDS chapter 16. You can do these char calculations for exposed wood. And when you go through these char calculations, basically you're going to have sacrificial wood on the outside. So if you have a 1 hour rating on your floor system, then your floor is going to be basically a 1 hour floor with some additional wood on it, right? Now, there are some stress reductions when you go through those calculations. So you may or may not actually have to oversize your floor because obviously during a fire, you're not anticipating the full live load. On a floor system, you're anticipating that people have exited the building at this point. But basically the wood is providing its own fire protection. And that has been proven to work well for type 3, 4, and 5 construction over the years. But now we're talking about going taller. So are we going to simply rely on this or are we going to look at it a little bit more in depth? And obviously that's what they did was look a little bit more in depth. So the ad hoc committee established these 6 performance objectives. And the number 1 performance objective, no collapse under reasonable scenarios of complete burnout of fuel. So in essence, all the stuff that's going to burn within this space burns and goes out and that there's no collapse within the structure. And that's with no sprinklers activation. So that's like worst case scenario, right? And they actually have done a full scale compartment test of this. And I've got a video of it. It's really interesting to see. Now, scenario number two, we want the sprinklers to actually work, right? We don't want complete burnout of all the contents. So we want highly reliable fire suppression systems. So there's going to be a little bit more stringent requirements when it comes to sprinklers in a tall wood building than you would if you were under 85 feet or 6 stories and less. So just know that. I think the fire protection guy earlier was talking about how big the pipes would need to be, the standpipes would need to be for the fire suppression. It might very well have to be things that we would need to consider very carefully because we want to make sure that we've got good fire suppression within these tall wood buildings. Number three and number four are pretty related to each other. One, we don't want to have a lot of high heat generated by our building that's going to catch an adjacent building on fire, and vice versa. We don't want an adjacent building to catch our building on fire. There was a very well-publicized fire in the UK of a tall building that had combustible materials in their exterior. And one unit that caught on fire, the fire spread to the exterior skin of the building, and it was a tragedy. So in essence, what we're dealing with in these tall wood provisions is that we're going to have limitations on what can and can't be used in that exterior skin of the building, so we don't have issues like that related to it. Then the last one, no unusual fire department access issues, and obviously egress systems designed to protect the building occupants. So you're going to have some more stout fire resistance ratings for those exit corridors. So one of the things that was really interesting when I started working for Woodworks and I started looking at fire tests is that we test a very limited portion of our buildings when we talk about the fire tests that we have. When you talk about the UL assemblies that you have to come through for a wall, in essence, you're really just testing that one wall assembly. You're not testing a full scale test. You're not testing the intersections. And I know I've had conversations with Kirksey about basically the question of the floor system interjecting with the wall that's supposed to be non-combustible, and how you have a 1 hour floor and a 2 hour vertical wall, and how those fire resistance ratings works. And so that's the issues that go along with, fire resistance rating, is what happens when they come together. So a full scale test was commissioned to basically create a 2-story apartment or 2 levels of apartments with additional weight on top to simulate more stories above. And we did a wide variety of tests within these apartments. So here's some of the images from the spaces. One of the things I have to stress is that, yes, there is fire and flame. That is the contents of the apartment. That's not the structure of the building. There's a fire load within these spaces that is set on fire to generate these fires. And then that's exactly what they did in these spaces. So 5 different tests were done, and they correspond with some of these new construction types that we're going to be dealing with. So test number 1, all surfaces are going to be protected with Type X gypsum and no sprinkler activation. Okay, so there is going to be no exposed wood in test number 1. You're going to have everything covered with gypsum, but you're not going to have any sprinkler activation. Test number 2, we're going to have partial exposure of the ceiling. Test number 3, partial exposure of a wall. Again, no sprinkler activation. So you're going to have exposed mass timber. There's going to be a fire within the space. How does that mass timber perform when it's exposed to a fire? But it's only partially exposed. It's not fully exposed. And then tests 4 and 5 are going to be tests for fully exposed applications. One where you have normal activation with sprinklers. It's a very boring test. And then one where there's a delayed 20-minute activation of the sprinklers. And that 20-minute number is sort of interesting. I'm going to play you a video of one of the tests where basically the contents are allowed to burn out. And I want you to remember that 20-minute mark, 20-minute mark, to see exactly how consumed these apartments are at the 20-minute mark. So in test number 5, again, we have fully exposed mass timber. Sprinklers are delayed by 20 minutes. And so we'll see how intense the fire can get within a 20-minute period before the sprinklers actually activate. So here's just some images from test number 1. Again, this is fully encapsulated. So all the mass timber is covered with Type X gypsum. And you can see the flames were pretty intense within the test, but it burned out on its own. There was no fire services brought in to put this out. It simply extinguished the rest of the contents. And in essence, it performed exactly the way we wanted it to. All the gypsum was still intact. There was no damage to the mass timber. It survived the test very well. Test number 2 and 3, where we have our partially exposed. Here's some of those images from that test, and you can see on the lower right and lower middle, the charred remnants of where we exposed the mass timber. But again, that's what we anticipated. We anticipated that the mass timber would burn and char. And when it chars, basically it prevents that fire from propagating through the mass timber. I mean, who here has tried to go camping, set a big log on a fire and tried to light it with a match, right? It's just never going to go. And then if you don't have any small kindling pieces in there, it's going to go out on its own sometimes. So you have a hard time keeping these large sections burning. Test number 3, this is the same test as number 2, except the wall is exposed. Test number 4, this is the boring one. That's the normal activation of the sprinklers. So, I mean, the cabinet's got a little charred. That's about it. And then test number 5 is the one where the sprinklers were delayed. So this is an image of the full-scale mock-up, so you can sort of see exactly what they did. It was a pretty large-scale test. I don't know exactly where that testing facility is, but that's kind of cool. This image really shows you the contents of what's inside the apartment. So you can see there's chairs in there, there's beds in there. But what you'll also notice is there's a bunch of extra wood pallets in there. They actually generated a much larger load than normal for these types of tests. So then the fires are always started in the kitchen underneath the cabinets, and then it will spread to the living room and then spread to the bedroom. And once again, despite how intense that fire looks, the structure itself is not the one that's burning. It's all the contents. And then basically it's going to self-extinguish with a few hot spots in there, and the test performs pretty adequately. So this is our video. There we go, it's starting on its own. So this is the video of the test. This test takes about an hour, but obviously it's sped up at various times throughout the video. One of the things that I want you to keep an eye on is in the lower middle image, that door there. It's a 1 hour rated door. And you'll notice that when we hit about 1 hour in this test, that door just goes, falls over. So it's sort of funny how that 1 hour door works. So here you can see the fire starts in the kitchen area and then spreads over to the living room space. And at various times, some of these cameras will go out because they're obviously, sacrificed to the flames. What's the fire god? What's the name of the fire god? I need to use that in a previous station. Ra, it's the sun god, right? I'll have to do a little research into my Greek mythology. So at this point, we're about to have flash over into the living room where basically the space gets so hot that everything almost instantaneously combusts at the same time. In the meantime, though, you can be sitting in bed watching TV and you're completely fine, right? It hasn't made its way into the bedroom yet. Hopefully the smoke detector has gone off at this point. The thermal image on the lower right is also kind of interesting to see, where you can see exactly how intense it is within the living room space and hasn't quite made it over into the bedroom space yet. Now look at the time at the bottom. This is at 16 minutes. So in that one test that I talk about, the sprinklers are delayed 20 minutes. So now basically we've got flames encompassing the living room and the bedroom. And all the contents within those spaces are now burning quite happily. And again, we've got load on top of this setup right here to simulate additional stories on top of this structure. So it's carrying substantial load on top of it. Now in this test, you'll see in the upper right, you can see this is the test where we had exposed ceiling. So those black areas in the ceiling, that's exposed mass timber right there. We're hitting the 1 hour mark. Keep an eye on the door. Like right on schedule there. So that was a really interesting test. Now, again, there is not an ASTM test that requires us to do that. That was something that was a grant that was done to sort of study the effects of what we're basically going to be dealing with in these tall wood buildings. So that wasn't the only test that was done, though. There were a lot of other really important tests that needed to be done to prove that mass timber can work in a tall wood structure. And so different organizations, different manufacturers have all been doing their own testing to prove their materials can work in this. Now, one of the things that changed in the 2021 is that the PRG 320 requirements for certification were updated. The glues that were used for that certification were updated. And this image on the left shows you one of the most important tests that you might have. So we know cross-laminated timber is a glued system. You have laminations running in alternating directions, and they're glued together. So what happens to glue when it gets hot? You might automatically think, well, it just melts and it drops what it's holding. That's obviously what we don't want to have happen in a mass timber building or in a tall wood building. So in essence, what we have are glues that can withstand elevated temperature tests. So this image on the left shows a CLT panel that has been put through one of these tests to prove that the glue will not drop a lamination, because obviously that glue softens or fails completely. That lamination drops. Now all your charring is gone and it just starts right over again on that exposed surface. So that's a scenario that we don't want to happen within these spaces. So that new certification that I believe all manufacturers are now in compliance with was very vital to get this tall wood application pushed through. So it was approved. Some of these things were approved pretty unanimously. There was a little bit of debate on some, but the changes were approved in the end of December of 2018, and the final votes were ratified in January of 2019. And like I said, most everything passed pretty easily. I think the lowest one was right around 70% as far as, and it just required a simple majority. So a lot of these changes that occurred were passed relatively easily. So what are these changes? What does this mean for us? Wow, how tall are we going to be allowed to go? So since the IBC, its original in 2000, the IBC 2000, we've had these 5 different construction types and subcategories of A and B for types 1, 2, 3, and 5 had subcategories. Type 4 didn't have a subcategory. So you had type 1 and type 2 construction. That's going to be pretty clear non-combustible materials. You're not allowed to use combustible materials in type 1 and 2 unless you like reading the footnotes. Who likes reading the footnotes? Well, if you wanted to put glue lam in your roof, then you could read the footnotes and you could put glue lams in a type 1 or a type 2 construction, but it can only be used in the roof surface. There had to be limitations as far as heights and all that stuff that you find in the footnotes. But in general, type 1 and 2 construction was limited to non-combustible materials. Type 3, 4, and 5 allowed combustible materials, and we typically found light frame construction dominating type 3 and 5, with type 4 just sort of being there in case somebody felt like doing some heavy timber stuff, but nobody ever really did that, right? I had a conversation with a major city in the state of Texas that will not be named, it was not Houston. And they were not even really sure after I met with them that type 4 construction was allowed. And I just was trying, I sat with them, talked with them for an hour. And then as you're walking out, you're shaking hands with somebody and they say something like, I don't know if that even would work. And you're like, it's in the code. But it wasn't really utilized until mass timber came along. And so when mass timber came along, and this is one of the debates you have with mass timber, and the architects in the room that have done mass timber buildings, I'm sure Kirksey can speak to this themselves, is that, okay, I'm going to do a mass timber building. What construction type do I use? Do I use type 3? Do I use 4 or 5? Is it 3A or 3B? Because there's a big difference between that. You go 3A, you got a fire rating for your floor. 3B, there is no fire rating for your floor unless it's multifamily, and then you might have a fire rating for it. That affects obviously the thickness of your CLT panel. You might think, oh, it's heavy timber, it's mass timber, I'm going to do type 4 construction. Well, in type 4 construction, you're not allowed any concealed spaces. So all of your MEP equipment has to be exposed to the occupants of the building. And sometimes that's okay, sometimes it's not okay. The project here is type 3A construction, 3B, okay. I'm gonna make sure I get it right. 3B construction. So we can do concealed spaces in type 3B. So we have lots of areas here with concealed spaces hiding all of that mechanical equipment. And if it's 3B, then we don't have a fire rating for the floor, correct? So then we don't have to worry about thickening our floor up for that. So that was a good choice for this project. But in general, you had this debate about whether I use type 3, 4, or 5. So what's happened though is that, yeah, I just went through all that on that slide. I tend to do that sometimes. What happens now though is that our type 4 construction is changing. And there's significant changes, I think, to all of it across the board. We have type 4A, B, C, and HT. Now, if you are familiar with type 4 construction at all in the older versions of the code, type 4 HT is that exact same thing, except we're allowed concealed spaces now. We're going to allow to be doing concealed spaces in type 4 construction, type 4 HT. We're still limited to 85 feet. We're still limited to 6 stories for B occupancy. We're still limited to 5 stories for R2 occupancy. So nothing really changes in type 4 HT, except the name gets changed a little bit. But we have this type 4 A, B, and C. And it's not like the A and B in the other ones. This is all based totally on heights and areas, A, B, and C for this. So that's what the big change is. So what are they? Here's our new building types. Type 4A, we're gonna get to go really tall. We're gonna get to go up to 270 feet and 18 stories. And again, like that Minneapolis project I talked about that was 7 stories tall, you can put a concrete podium underneath this. You can do 18 stories of mass timber, then you can do a concrete podium. You just got to make sure it's underneath 270 feet tall. And we've got a project that's looking, so it's very similar to that type, except it's got cooler stuff on it that I'm going to talk about here in a few minutes. Now, in type 4A construction, we're going to cover up all the mass timber. And I know you're going to say to yourself, well, why in the world would I build if I'm not going to be able to show the mass timber? Well, when we talk about speed of construction that's advantageous for a 3-story building, you multiply that by 5 for an 18-story building. You know, you see really incremental increases in speed of construction when you start looking at these tall buildings. Type 4B construction, 180 feet and 12 stories, partially exposed mass timber. I'll get more into that a little bit. And then type 4C, fully exposed mass timber, but we're limited to 9 stories and a height. I'll talk about that in a second, because it's, who's ever seen anything in the building code that just doesn't make any sense? Why is everyone laughing? It's the building code. All right, so let's talk about these in a little bit more detail. Type 4A construction, 18 stories, 270 feet. So this is very similar to the project that occurred in British Columbia, student dormitory for Brock Commons. So they had this 18-story building. It was actually 17 stories of mass timber on top of a 1-story concrete podium. But if you see that image on the lower right, everything's covered up with drywall. There is no exposed mass timber within that. Now, what was really cool about this project is that the 17 stories of mass timber were erected in a little over 2 months. So they went from a concrete podium and 2 elevator cores made out of concrete to, in essence, a fully topped out building in a little over 2 months. That's how fast they were able to go with that mass timber installation. And this project also, we talked about prefabricated exterior elements. This project had prefabricated exterior panels as well. So not only did the building go up in that 2-month time frame, but the exterior envelope went up in that 2-month time frame, allowed them to get that building done very fast. The other thing that was neat about this, 1 dumpster full of waste material on the job site. That was it. So they didn't have to go through a million dumpsters. All those little things add up cost-wise. So 100% non-combustible protection on all mass timber surfaces. That's the big, I wish we didn't have to do that stuff. Now, future versions of the building code, we might start to look at pushing beyond 100% coverage. But for now, what we're dealing with is 100% of the non-combustible, 100% non-combustible production on top of all the mass timber. So heights and area wise, for B occupancy, where this is probably going to be the most popular, or possibly R2 for residential, 18 stories, 270 feet in height. And you're talking about some pretty substantial building areas as well. You're talking almost 1 million square feet, which you could probably push it over 1 million square feet if you look at frontage increases for that B occupancy type. So we're talking about substantial projects. Again, you don't build very many of these, but if you're going to build an 18-story building, it might be worth looking into mass timber as an option, as opposed to your more traditional concrete or steel for those for that type of structure. Type 2B construction, we're going to allow partially exposed mass timber. How much? Not enough. I'll tell you that right now. I want to go for 100% exposed mass timber, but they are not going to allow you to do fully 100% exposed mass timber at 12 stories and 180 feet. So what we're talking about is 20% of the ceilings or 40% of the walls. That's if you have mass timber walls, which in all honesty, we don't see that often load-bearing mass timber wall systems in buildings of that height. Most of the time it's post and beam construction and you don't have any mass timber walls. So in essence, what you're looking at is 20% of the ceiling is what you're going to allow. That's not a lot. It's just not a lot. It's not enough. We need to do more. Why is it so low? Because the testing that we had done to prove the tall wood stuff was done back in like 2015 or 2014. And we weren't really thinking at the time when we did that test that this information was going to be used for a potential construction type with exposure. And when committees say, well, you only did a test where you exposed 20%, that's all we're going to allow you to do. So we could have done a test with 40% or 50%. It probably would have passed, but we didn't do that test. So there's new testing going on right now that is going to improve this within the next version of the code. If you do have mass timber walls and you want to expose 40% of them, and you have mass timber ceilings and you want to expose 20% of them, you got to separate the two. You can't have a wall that goes up into the ceiling. You got to separate them because they weren't done in the same test either. Anyway. So again, heights and areas, 12 stories for the most popular types, B and R2 occupancy, 650,000 square feet just about for B, and 370 or about 370 for R2 occupancy. So pretty decent sized buildings. All right, types 4C construction. Now we're talking fully exposed mass timber, right? 9 stories tall. Excellent. 85-foot limit. What? 9 stories, 85 feet. Can anyone squeeze 9 stories into 85 feet? Is it dumb? It's in the code though. I can't change it. I can't get my white out and put in 10 stories. I can't go out and put in there 95 feet. It's the dumbest thing I've ever seen in the code, and that's saying something. But that's unfortunately what we're dealing with. So in essence, what we're looking at is really still that 85-foot limit that you could have gotten with type 4 construction with a podium. Now you can do it with a fully exposed mass timber. But I'm going to caution you about that because what you're going to find is that you're going to have a fire rating now with type 4C construction. And if you know anything about type 4 construction, there's in essence no fire rating. And what that means is that you have minimum sizes your members have to meet, but there is no 1 or 2 hour rating for the primary structural frame. There is for the exterior building envelope if it's load bearing, but it might actually be less expensive to build type 4 HT with a concrete podium than type 4C fully exposed mass timber. So you want to really look at that very closely. If you're looking at a 7-story building that you want to do out of mass timber, really evaluate exactly what's going to be the most cost effective. But it is a start. Hopefully the next version of the building code, that 85 feet number is going to get changed to something else. But we can do fully exposed mass timber. We also can do concealed spaces within all of these. Obviously, if you do have concealed spaces, they're not going to allow combustible materials. So I say fully exposed mass timber. That's except for the concealed spaces. You're going to have non-combustible protection within those concealed spaces. And again, we got 9 stories for B occupancy, 8 stories for R2, but we're again still limited to our 85 feet in height that we are saddled with type 3A construction as well as type 4 construction. All right, so in essence, what we're dealing with is now we're sort of comparing these type 4 constructions to what we see in type 1A and type 1B. You're never going to get up to the unlimited heights and areas of type 1A, although if you pay attention to mass timber articles at all, there was an article that came out recently, I'd say within the past year maybe, about a 70-story mass timber skyscraper in Japan. That was a study that was done. That's great. Let's go to 20, 25 first before we start jumping to 70. So we'll get there, but we're not going to compete with type 1A unlimited at this point, but that's really what type 4A is talking about as far as heights and areas for a large majority of type 1A projects. And then type 4B comparing more or less to type 1B construction as far as your heights and areas. So it's very similar in the limitations on those. So what are we talking about with fire resistance ratings though, right? We want to make sure this stuff works. So what is our fire resistance rating for type 4A? It's going to be primary frame or bearing walls, 3 hours throughout the building, 2 hours at the roof. That's going to be a combination of non-combustible protection in addition to wood charring. So you're going to get part of your fire resistance from non-combustible protection, part of your fire resistance from charring. And if you want to go through this in more depth, we actually have a handy paper that goes through this more. And then as you go down to type 4B to type 4C, your fire resistance ratings will drop a little bit, although there's not really much difference between type 4B and type 4C. And that's why I urge you to look at type 4 HT construction if you're considering type 4C, because look at that, your floor construction has a 2-hour rating, but in type 4 HT, it in essence has a 0-hour rating. It just needs to meet a minimum thickness requirement, which is probably going to be met simply by the structural or the vibration design of the floor system itself. So if you're looking at type 4C construction, you might be saddled with additional fire resistance ratings that you may not have to worry about it with type 4 HT. But there are other subtle little differences in there as well, concerning partition walls and fire ratings with them. So you need to look into the issue very closely when you're looking at that. So what are we talking about with the materials? Exterior walls, you're allowed to use mass timber, but they have to be protected with gypsum, mass timber or non-combustible. This is the other thing that comes up. If any of you have done type 4 construction, type 4 construction talks about, for fire resistance, the members have to meet minimum heavy timber requirements. It doesn't say anything about what steel has to do in type 4 construction. It doesn't say that you need a 1 hour or a 2 hour or a 3 hour rating for a steel element in type 4 construction. So we've all been in heavy timber buildings that have bolted connections, right? And plates or bearing plates or seats that the beams are sitting on, right? If those are steel elements, in essence, do they need to have incandescent paint? Do they need a 1 hour rating, a 2 hour rating? The code doesn't say at all in type 4. It's very frustrating because I've had architects call me. They're like, well, we want to put a steel column here for this. And I go, well, you need to figure out what you want to do. And hopefully the authority having jurisdiction is okay with it because there's nothing in the code. Now in type 4, A, B, and C, it's very clear. You can use non-combustible materials. You can use mass timber, but you obviously just have to meet the fire resistance rate, 2 hours, 3 hours, 1 hour, whatever it is. So if you have exposed steel, then you need to provide 1 hour of fire resistance, a spray fire resistance or intumescent paint, whatever the case may be. Am I doing time? I'm doing okay. All right, so all this information is summarized within a paper that we have available on our website, Tall Wood Buildings in the IBC 2021. So if you want more information on this is a free download off our website. Everything on our website is a free download. It's the best deal in architecture and engineering these days is getting stuff from Woodworks. It's all free. So feel free to download this. But what's exciting though is that some of these projects are already starting to happen even before the IBC 2021 has been adopted fully. We've had some jurisdictions that have approved it early or the tall wood portions of it early. I'm not sure if I have a slide in here with it, but there was just one that came out the other day. I can't remember who it was, Massachusetts maybe. There was another state that adopted it. Oregon has, Washington has, California's looked into it. Utah has, the city of Denver has. There's already jurisdictions that are embracing these tall wood code provisions and looking at it. So these last two projects I want to leave you with, though, are really interesting ones. So this is called Intro in Cleveland. This is a 9-story project, 8 stories of mass timber over a 1-story concrete podium. This was a project that has been through a very long process, but is now under construction. They've got mass timber installed on it. This is happening. It's real. 2 years ago at the Mass Timber Conference, I spoke with the building official from the city of Cleveland who looked into this project and approved it ahead of time. We were already looking at the tall wood provisions, but nothing had been codified yet. And so they basically adopted the early draft versions of what the tall wood was going to be. What's interesting about this is that I told you before, there's that 20% limit as far as exposed ceilings. This project goes beyond that. I believe they're pushing it closer to 40 or 50% of the ceilings are exposed within this project. So we already have precedent being set that we can expose more of this mass timber in what this would be type 4B construction. The other one, though, this one blows me away. Ascent in Milwaukee, 25 stories tall, 19 stories of mass timber over a 6-story concrete podium. And again, if you remember type 4A construction, we got to cover everything up. You can't have any exposed mass timber. Well, what do we see in the image on the left? This project has exposed mass timber in it. This project, I wouldn't even describe it as type 4A construction because it's so different than what type 4A construction is going to be. This, in essence, is type 1A construction with an authority having jurisdiction approving mass timber materials in a type 1A building. And this is really exciting. Again, this is under construction right now. They're working on the concrete podium, but they're moving forward with this project is going to be mass timber. Another great precedent-setting project here in the United States. With that, I'm going to skip over that because I think if there's any questions, we've got about 10 minutes for questions. I can't run around with the microphone from up here. So do we have any questions? Can we unhook this microphone here and pass it around, or take one down, pass it around, 99 balls of beer on the wall? Kids can't sing that song anymore. It's a tragedy. Elementary school. That's when I would sing the 99 bottles of beer song in a school bus full of children, and nobody thought a thing about it. It's crazy.
The last two project you showed us,
Yes.
what's the basis that the AHJ approved these two projects if it's not in the code?
So I did speak with the building official in Cleveland, and he is a former carpenter, and he is a lover of wood. Now, you're not always going to get that. And so that building official, he did his own research. I mean, he was at the Mass Timber Conference. Most of the time, that's not something for building officials to go to. It's for architects and dreamers to go to. But he was there. He did his own research into these tall wood provisions. He evaluated the testing that was done, and he felt that they could go with more exposed mass timber and obviously adopt these provisions, even though the city of Cleveland hadn't adopted the 2021 IBC yet because it hadn't even been published at that time. So you have a very unique scenario where you've got a very forward-thinking authority having jurisdiction. And I'm not as familiar with the Ascent project in Milwaukee, but I did watch a webinar where the developer spoke about the project, and he said that it was a very lengthy process, and that at the time he was a bit naive and felt that they could conquer the world. He said in retrospect, if somebody had told him ahead of time how long it was going to take to get the approval process, he would have said, I'm not going to do it. But now that he's gone through it, he's very happy that he went through all those steps. So I don't know all of what happened to get that approval. I can only imagine. I know that our regional director for Woodworks was very involved in the project, the American Wood Council. They dealt with the building codes and building officials. They were very involved in the process. It took years, basically, to get the approval for a project like that. It's not like something where you complete your construction documents, you send it off to the city for permit, and then you wait for comments to come back. That's a disaster waiting to happen. You got to be proactive with the building officials. You got to work with them. You've got to allay all their fears and make them comfortable with it. Now, that being said, that all started before the IBC 2021 had even been, really fully formed. Now we've got projects like that one, we've got the code. It's much easier to go to a city and get them to buy off on something of this nature. I'm not telling you it's going to be easy because I think there's still resistance among, especially the fire marshal and the fire departments about doing 18 stories of exposed wood because they think they're dealing with apartment fires of light frame and it's totally different. So there's challenges with projects like that. I'm not going to lie to you. I'm not going to tell you that we should all be doing this, but I think in the years to come, we're going to see more and more of these projects and make it more feasible. Any other questions? Fire away.
With record lumber prices, have you seen a withdrawal in potential projects? And what are y'all forecasting for long-term, short and long-term lumber?
I'm sorry, your microphone cut out. I didn't hear any of it. Lumber prices? What are you? This is the first time hearing of this.
1,100 a board foot.
I don't get phone calls weekly about lumber prices. So lumber prices, yeah, it's sort of amazing when you think about how much lumber has gone up here in the last year. Aaron, are you going to address it at all? Thank you. it's been a combination of things. I mean, we've had some plant slowdowns because of COVID. We've already had unprecedented demand when it comes to multifamily and single family housing. We had I can't remember who he was with at the time, but he was, talking about how you can't find pressure treated wood at Home Depot because everyone's building a deck on their house, right? So it's been really interesting. Now, that being said, I'm hearing that lumber prices will start to normalize to a certain degree in the near future. Does that sound generic enough? I don't know if they'll ever come down to the point where, we saw them before. One of the things that I can tell you though is, God, I wish I had thought of this question when we had Nordic on the line, is that, when you talk about mass timber, when you talk about glue lambs, you're not talking about just the basic price of lumber. They have their manufacturing that goes into it, and those costs have not gone up. Glue costs haven't gone up. Presses that make CLT haven't gone up. Electricity costs haven't substantially gone up. That all goes into the manufacturing of mass timber. I'm not going to say that it's like 90% of the cost of mass timber, because we're still talking about the large bulk of the cost being tied up in wood fiber. But, we don't have, it's not as bad with mass timber as it is with regular stick frame construction. And before I say anything more, I'm going to let Aaron address it when he comes up and talks here in a few minutes. Yeah. Speak now or forever hold your peace. Oh, but there's another question?
We have a question from one of our virtual viewers.
Oh, excellent. Welcome, virtual viewer.
A two-part question.
Oh, no.
So following a fire event, how is the integrity of the charged section restored so that it would withstand a potential second fire event in the future?
Oh, you just roll the dice, take the chances. No. Strike that. I didn't say that. That's not on the record. So we talked earlier about some of the potentially damaged lamellas here at San Jacinto, and how, the installer was like, don't worry about it. We'll come back and fix it later. For minor type of fires, you might very well be able to do a relatively easy fix to get it back to its pre-fire condition. The problem that we have is that it's not really a problem, is we haven't had a lot of fires within a mass timber building to really, investigate real thoroughly what those repair options are. You have the ability to remove and replace materials. And we've had some instances where they've been able to take out a whole CLT section and roll in a new one. So I think there's methodologies that people are thinking of to repair this. We just haven't seen them practically applied as far as I know. I haven't heard about any of these applications yet. Certainly, if there is a fire within the space that causes substantial charring, then there's something has to be done. You can't just say like, oh, well, there's enough strength left in there, it'll be fine, right? We just have this one area. That's not gonna fly. We're gonna have to look at repairing those materials, and whether it's a re-glued in lamination or if it's a screwed in system, there are ways of removing that material, sanding it back, and putting a new section in.
It's an MT building that has experienced a fire no longer remedial.
Can you repeat that?
I didn't have the pen on, I don't think at the beginning. At what point is an MT building that has experienced a fire no longer remediable?
Oh, wow. Fastball right at me. That is really hard to say. I am not a fire rehabilitation expert. I'd really rather not venture a guess, which is what it would be at this point, to know if a fire, let's say we have a multifamily building, and if there's a fire within one of those apartments, can we repair it and get it back up to running without tearing it down? Probably so. I wouldn't see that that'd be an issue. What if it affected a dozen units? What if it affected 50 units in say a high rise? Then obviously we start to look at economics of what those repair costs versus tearing the building down and replacing it. And that's way, way beyond my scope of what I understand about, repairing all this stuff. So I dare not venture too much of a guess. I don't want any more questions after that one. All right, with that, I guess we can jump back into the next session.